Suppose we have a following data. There are three operators, Babita, Sagar and Kiran, who are measuring the percentage purity of 10 drugs. Now they are using two samples of each of the 10 drugs and they are taking different measurements. So what kind of data is this? This is a measurement type of data. Now the measurement type of data measures the characteristics of a part or process such as length, weight or temperature. The data can also include fraction or decimal values. The measurement system analysis we use for the measurement type of data is Gage R and R. The other measurement system analysis pathway is attribute measurement system analysis, which we will be studying later. First of all, we should set up a Gage R and R study in a custom worksheet. Minitab automatically creates columns for operators and parts and randomizes the order in which the measurements should be taken. For this, click the Stat, click the Quality Tools, and click the Gage Study, and then click Create Gage R and R Study Worksheet. Suppose there are 3 quality control officers who are testing 10 batches of the product and they are repeating the study 2 times. It's just to make sure they are not causing any errors. Let's write the operator name, Babita, Sagar and Kiran. And let's click OK. So we see here that there are 3 operators who are repeating the experiment, each experiment 2 times. There are 10 batches of the product. So they should conduct the experiment for 60 number of times. 10 times 3 times the replicate is the total runs or the total number of experiment they are running. So we have 60 number of experiments. Now parts 9, operator Sagar means Sagar is analyzing the purity of a drug of batch number 9. Sagar 3 means Sagar is analyzing the purity of the drug of batch number 3. Similarly, Kiran 8 means Kiran is analyzing the purity of the drug of batch number 8. After each of these operators or quality control analysts analyze the purity of drug, they got the measurement as shown in the column C4. Now, in order to analyze the results of this Gage R and R study, you go to the Stat, Quality Tools, Gage Study, and Gage R and R Study and Crossed. The Gage R and R Study Crossed window appears. In this window, for part numbers, select parts. For operators, select operators, and for measurement data, select the measurement and make sure you click the method of analysis as ANOVA. Then you should go on the options tab on the side, click on the options. Under the study variation, the 6 number of standard deviation is already entered. You have to enter at least one specification limit. Suppose the lower specification for the drug to pass purity is 95% and the upper specification is 105%. In case if dose of the drug is higher than the specified value. And then let's select the alpha to remove interaction term as 0.05 as usual. And then let's click OK. Finally, you click on OK of the Gage R and R crossed window as well. Now in the graph generated over here, you can see the various important information like R charts by operators, X bar chart by operators, etc. The important parameter to see here is a total Gage and R contribution. Here we see that total R and R contribution is 100% and 100% contribution is due to the repeatability error. So ideally, the Gage R and R contribution should be less than 10% and anything less than 30% is acceptable under some condition, but anything above 30% is not accepted at all. The 100% error is due to the repeatability, so there should be the 100% error in the measuring device itself. And one important thing that we found here is that contribution is not due to the operators, so there must be error in the measurement device itself. Now the error caused due repeatability suggests how much variability in the measurement system is caused by the measurement device, and the reproducibility deals with how much variability in the measurement system is caused by the differences between the operators. The 100% contribution to the gauge is given by the repeatability, so we conclude that there is a problem with the measurement device itself. But we don't want to stay up to these results only. We want to dig a little further. So inside the gauge study, you should run the gauge run chart. You'll see a window like this appears for gauge run chart. Let's select all the parameters. In the parts number, select the parts. In operators, select the operators. In measurement data, select the measurement data. And then let's click the OK button. If all the operators Babita, Sagar and Kiran had the same reading, then these lines would be horizontal. Since there is an error in a measurement device, the operators are giving different results.